So yeah, my name is Addison, and I'm here to present about my perspective on how to create APIs as a reverse engineer. So I come from Colorado, and I went to university at the Colorado School of Mines, and I presented talks at the Linux users group there. And I have presented 10 talks, but I've since graduated. And I'm a hobbyist reverse engineer with experience in geospatial APIs, transit, and video game APIs. And I'm also a data scientist from school. I have a data science degree. So one of my interests in that space is I really enjoy creating custom clients for APIs. Like, for example, my most popular API is the public Mario Maker 2 API, which players use to get metadata about levels and also level files themselves so that they can render them and use them to play the game. So why should you care about making an API really good and treating it as a completely different thing to improve as a part of your service? I think that APIs are the primary way both non-human consumers use their service. For example, AI scrapers, we may not like them, but some services could really, we have to cater towards AI scrapers, it feels like nowadays. And we also have to cater towards other services, like, for example, bots that monitor the uptime of a service. You need an API that's capable of serving data to those bots that will be querying constantly. But also, human consumers use your service through alternative means, and that comes from my background as a reverse engineer making custom clients. People sometimes use your service in a way you don't expect. And also, it gives your service more reach than otherwise possible. Sometimes the front end that you create is not the one that your users are looking for. Maybe it's not fast enough for them, or maybe it doesn't have the automation tools that they require. And I think some clever examples of tools that show the flexibility of allowing an API to have this much information exposed is Steam Database is used by both developers and gamers. Gamers to see what games are popular, but also developers to gauge trends in the industry. And 50,000 websites use Twitter embeds, and the Twitter embed is only possible because of a very good free system that developers can use to have access to Twitter tweets. And Terraform is an infrastructure as code platform. It has 1 billion plus downloads, and it is primarily just a custom client for cloud APIs, for cloud providers. I've used the Google Cloud Platform UI. It is the only website that lags my MacBook M1. So Terraform is kind of a godsend in that way. I need the APIs because the front end provided by Google is not sufficient for me. So what makes a great API? I distilled it down into 4 data points. So latency, the speed of the API; quantity, the amount of data that an endpoint provides; coverage, the total coverage of all the endpoints in relative to your service; and the quality of the API in general. And the way that I depict coverage here is coverage is just what amount of your service is covered by some sort of data source. Are there parts of your service that don't have a public API that people can't use to do things? And quantity is just, is your endpoint capable of serving as almost everything that your service provides on that particular topic? So latency, serving users fast with minimal overhead. Minimal overhead in this means you don't want to, cause your server to burst into flames. You want to be able to serve people quickly, but not at the expense of your own hardware. So this may or may not load, but I reverse engineered Baidu Maps, which is a really popular mapping platform in China, and it basically is the analog for Google Maps here. And I was extremely surprised to find that, frankly, it is slow. That right there is the actual realistic raw speed of the Baidu Maps front end, even if you operate it just as you would with the exact same interface as Google Maps, in fact, even more restrictive, Google Maps is doing more here, it's still much slower. And imagine being on the road trying to determine how to get from an airport to your hotel, and your mapping platform takes that long. But then information changes. Suddenly, you find out there's a detour, so you can't take a major bridge. That means that bus is no longer usable. But wait a minute, Baidu Maps takes like 10 seconds to determine that information. It's simply too slow for users. And another example of this is, in addition to custom clients, I make custom servers for things. So I made a custom server that replicated the API of Mario Maker 2, so you can connect to my server with a modded switch directly. And the API I designed was designed precisely so these exact endpoints are fast. I didn't design it for ease of use for development. For my own use, I designed it so that people would be able to use my service quickly. So I have these somewhat complicated queries, but I created an index so that those queries would be fast, because at the end of the day, what matters is the actual latency of the endpoints themselves. Your users don't really care what the quality of your backend is. They care whether things are fast. And another example of this, this is just a query that will give you, this is the original graphic that I had at the beginning of the talk was a visualization of a bunch of replays. These are the replays. And the request for them, which mirrors what Nintendo does, is this sort of union against times that are slightly slower and times that are slightly faster. But I need an index that makes that quick, because that's what my users are using. They want that data. And this is 2 examples of code that one of them seems pretty reasonable. I'm trying to get a world record. A world record is simply the smallest value in a table. So let's do an order by with a limit 1. Wow, we did it. We did it. No, we didn't do it. Let's make this super advanced code. Like, the code on the left there is a system that finds the current record owner, which has a flag that says is world record, desets it or deselects it, and then sets it on the new world record. That seems like a bunch of extra computation if I just want the world record. But I don't just want the world record. There we go. I need the number of world records that a player has. And imagine the amount of computation required to get a list of all the levels that somebody has played, and then get their time, their rank in that level, and determine whether it's a world record. We're dealing with basically like kind of O of n versus O of n times m is more of a correct analog. So that extra complexity was worth it because it sped up the endpoints that users are actually using. And unfortunately, if you're going to make things fast, that means certain malicious users need to be restricted from making requests quickly, because that's the basis for a DDoS, and DDoSes are an absolute bane of our existence. So sometimes clever engineering is not enough. I can create an architecture with very good caching and very good data structures, but at the end of the day, there are billions of people on Earth, and there's like millions of machines that could, in fact, try to slow down my service. So try to, of course, implement some system that will eventually just say no to a request. The way that I do that for my API is a semaphore system. So I have a semaphore that's set to 4. 4 people worldwide are allowed to make requests. That's pretty reasonable. My system has the additional problem that I don't want to overload Nintendo. So there's actually 2 users to please, my users and Nintendo themselves. So my way of satisfying that was simply a semaphore. And I think that APIs that are extremely fast are not just useful and convenient for people, but they enable entirely new avenues of discovery for using data. So an example of the top right message was, I released a endpoint that would return ninja times for this speedrun mode. And a few days after I did that, there was a new ninja that released for the game. And originally, people were submitting their times onto a spreadsheet that they had played. So there were ranks that people didn't know anything about. But if you have an endpoint that's fast and will give you that data essentially live, then you can get a live feed of world records, which was a really cool moment because people were tracking the world records second by second. And that was a really exciting few hours as people watched as the record went down and down and down. And I think that certain products like Google Takeout, for example, Google Takeout is not designed to be a live feed, and that's intentional. It's one of the best ways to get access to things like YouTube data if you want to do like analytics on a user and give them recommendations, but it's not live. It's delayed by a day, which significantly reduces its usability for a number of different possible use cases. And this is true of, I think, a number of us, is that we have this sort of exponential curve of users. We have some users who make a lot of requests, a lot of users who make very few requests. And in certain cases, you can trust someone and you can give them special exemptions to your service. So you can remove the rate limit on them. So there's a user who created a level viewer for my API, and I gave them a special exemption to the rate limit because I trust them. In fact, they're much older than me. They've been in this industry for longer. So I know that they make good decisions about architecture, and they're not going to overload my API. So, and quantity. So providing as much data as possible of some type over each endpoint. So an example for Mario Maker 2 is, unfortunately, and I know this, they only return the last 1,000 comments for each level, which that's because in-game, that's the number of comments you can view. But I know, because they return it as a field on one of their level info endpoints, that there's 133,000 comments. So more than 99% of the data that was created and uploaded to the service is no longer accessible. And sure, this is just Mario Maker 2 comments, but I would be somewhat annoyed if data that I uploaded to a service became inaccessible after like a few years. That's kind of an insult. So in cases like this, surely there's a better way that we can provide more information. We don't need to limit ourselves. And an obvious solution to that is pagination. So pagination is pretty simple because it creates this system that both rewards users, users who don't need your API that much, and users who use your API quite a bit. You have users who don't want 1,000 comments at once. So if they make that request, they want it to be quick because what they're really looking for is maybe just 3 comments, just a smattering, an example of what the API produces. But some other people, like me, of course, want all the data, and both of us can be happy. Just one of us can trade off convenience and time for that data. So I'm willing to spend more time as long as you give me an option to get more data, and that's what pagination enables. Just simply page 1, page 2, page 3. And another example of this is something like Whois. Whois is super popular for just normal people who just want to see, people who want to know where their requests are going to maybe gauge latency. For example, like running a trace route or something. All I want to know is just to see if there's a performance regression because of some particular aspect of my IP. But there's also people who want to run like trends and analysis on those IPs. And a service like Whois, this is the American, it's Aaron.net. Like Aaron provides a system that allows you to do a single lookup and a bulk lookup. So both people are happy. Because this use case is significantly different from the creating a map of the internet use case. And yet, truly both of those are valid. This gives us important information to know, like, what is the internet being used for? And I think that's pretty valuable. It's good to know, because we know that the IPv4 pool is going to be exhausted soon. It's good to know, like, why and how that's going to happen. And both of these services are equally valid. And this was an example I just finished recently, but I scraped, if you guys know anything about the Wii U or 3DS, those online services were shut down last year. And we had a few months to prepare for that. Well, I decided to scrape the entire service, every single game. It's somewhere in the realm of like 300 games that I downloaded, basically all the data they exposed. And the reason I wanted to do that is I believe it's digital archaeology to save information like this. But the technical details of how I did this, especially for leaderboards, is I used a form of pagination in order to obtain that data. And of course, people who play Angry Birds, they only care what the top 10 times are. They care what the world records are. But by using their API in such a way, I was basically able to paginate through the rest of the records, which creates interesting opportunities for data analysis and just gauging popular games. And it's an interesting avenue. And this is a world record chart, which I think is pretty cool. And quantity is also useful if you somehow provide some sort of cross-reference to another service. So this example here is this endpoint. In-game, people really only care about this endpoint to get just like world records, their rank, and also get a number of replay times around them. But because of the this right here, the player ID, which is this really extensible ID used all across Nintendo, I was able to completely scrape this entire service and create an interesting little map, which was not what the API was designed for, but it was made possible because there was this simple ID that I knew would work across the API. And yeah, this is 133,000 players, which is why it looks like a fluid simulation. So another example of quantity is progressive loading. So maybe you just have a few small pieces of data, but they have extremely high resolution. And the classic example of this is Google Maps. It's not just there in the tiling system of its, in the way that it serves its map, but it's also there in the way that it serves Street View data. So I reverse engineered Google Street View and made a custom client for it. And what I learned when I did that is that they use a resolution system. You can see this when you use Google Maps. You'll plop down the little yellow man, and it'll take like a solid 30 seconds for it to load at full resolution. And that's a clever design choice, because maybe I only want to see what color the grass is. But if I wait 30 seconds, once again, the trade-off for time versus data, then I can see the whole picture at the highest source resolution. So coverage. How well does your API cover the use cases of your service? So an example like Baidu Maps. I found that Baidu Maps is, and this is my shade section of the talk against Baidu Maps, which is why I'm not in China right now, is that it does an exceptionally poor job of giving me real on-the-ground directions. The only real data that it gives me is the train that I'm going to take. It's a very weird design decision where it doesn't give you point-to-point directions. It just gives you the main train that you're going to use, and then it gives you, it says, you can take a taxi to the train station. And I'm like, no, I'm not doing that. And I know for a fact Baidu Maps has access to this data because they do on mobile. They do in the app, they have access to this. But in the browser, they chose to deliberately reduce what data was accessible to the user. And what if I have my laptop on the train and I want to know how to get from my train station to my hotel? I'm not interested in downloading the app for many different reasons as a US citizen, but, but I'm not interested in downloading the app. So why would the API deliberately change what coverage of the service it provides depending on the platform? And in the example of Baidu Maps, in order to recreate the Google demo I showed at the beginning of the talk, I had to reverse engineer 2 additional apps. 3 times the amount of work for me? And also cases like accommodating new use cases, because you as the developer can't anticipate what sort of uses people are going to find out of your platform. So try to make it extensible enough that you can insert new endpoints that people request over time. And the way that that worked for me is gaming is a Discord native kind of thing. So people ping me and ping me and ping me all the time about various things they want added to the API. And over time, I add those features to the API. And one important thing is try not to deprecate your endpoints, because some developers are just slower moving than other developers. They might miss the fact that you deprecated. Yes, I know that versioning is this incremental system where you warn people about a deprecation before it happens, and you provide alternative ways to continue using the service. But in general, it's just a really nice bit of convenience for users when they can reliably know that an endpoint will exist for a long time. And also simplifying existing endpoints. Sometimes you made bad decisions. And sometimes you shouldn't deprecate, but it would be really nice if you maybe fixed up your mistakes. And also just the quality of an API. Because I believe that a good API enables new creative emergent uses of your service. And especially if you're the kind of service that people use for fun, which is why an example I used at the beginning was Steam Database, people will find that they have new, interesting reasons to have access to that data. And I think it really, it inspires people when they have access to that data well. So interoperability is something I talked about before, but if you expose global UIDs that are compatible with other APIs, then you can create a whole web of data. And sometimes one global UID opens up an entire avenue of experimentation. And an example in Baidu Maps was, well, the example in Baidu Maps is that there was no global UID. Really a shame. Nothing at all matches. The format of the name of a bus line changes. The numerical ID for a bus line changes. It's kind of unbelievable. But an API that does this well will create a lot of cool opportunities. Like if Baidu Maps had worked here, then I would have been able to properly recreate the functionality of Google Maps, which I did eventually do with a lot of string parsing, a lot of ad hoc string parsing. But if Baidu Maps did this properly, I wouldn't need to do that. And examples of good global UIDs you've definitely heard of is ISBN is not intended, of course, global UIDs aren't really human readable, but that's why we're at a Linux conference, so it's really nice to have computer readable stuff everywhere. And it's just a simple barcode that really enables you to do quite a lot of cool things, like learning whether a book that you really like is being archived forever by the Library of Congress. Or, making your own stock trading platform, but you want to add Apple there. Well, what's Apple's ticker symbol? And I'd say that the biggest API should probably become the global UID, or some sort of meeting group that standardizes these things. Regardless, somebody should step up and become the global UID, because competing standards aren't fun. And also, it's nice when an API is self-documenting, and that's really just not just are things interoperable, but are they obviously interoperable? So try to keep your naming consistent. In the case of Nintendo, I had to do the naming myself because I'm reverse engineering binary files. But for the public API that users use, I have very consistent naming schemes that people know that a data ID always refers to a level as a numerical ID. And also try to ensure that they take the same domain. It's really a shame when you learn that there's an undocumented portion of the ID space that is not accessible by that endpoint but is accessible by another. It's just not fun. And also, it's nice to have the right data format. This is just a surprising thing that I noticed in the Baidu Maps API. They serve encrypted payloads in base 64. However, and this is giving away my secrets, I simply took the encrypted out of the URL, and it became plain text. Oh my goodness. I was like, thank you, engineer. I don't know why you did that, but you saved my life. But this is not just like a weird attempt at security, but it's also just extremely slow. Like, why are we turning this encrypted, like, base 64 payload into, like, a binary file? Okay, it did end up becoming JSON, to be fair, but, like, if you're going to do that anyway, encrypt a protobuffer and send it to me instead. It would have been harder for me as a reverse engineer, but I would have understood that decision a lot more than what they went with. And yeah, just use well-accepted standards, because the way that you send data is not just for usability, but it's also for performance, really. And yeah, when the data format isn't right, a reverse engineer will make a new one, because that's what I did for the Mario API. Basically, all the data that I expose is a recreated standard that I didn't agree with. And even examples that go as far back as the format used for NES emulators. The ROM format people use, that's a reverse engineered, recreated format that has now become the standard. Because just give your users what they want, really. And also you want to do logging, because this was an interesting case where I had a user who made a lot of requests, 1.5 gigabytes over like a week requests, to this endpoint that is giving you multiple level infos for if you provide just a list of comma-separated level IDs. And what I learned is that this was a replacement for my inability, or my the fact that I didn't add an endpoint for multiple users, because there's a fixed part of level info that doesn't change. It's the person who first beat the level, because you can never beat the level first again. So they were treating it as a multiple user endpoint. The reason why is they wanted a tiny little leaderboard, because they were trying to basically just track how they were doing against their friends. It was kind of cute. But they were creating a new endpoint because of my inability to create one. And I only caught that because I was logging and asked questions. And also having example code, obviously. And not just having example code, but showing the different ways in which people might use your API. Because sometimes people are starting a new project, or your API is, your client code is really all-encompassing and does a lot of encryption, for example. People will want to use whatever client library you provide. But sometimes people have frameworks they've created, and your client APIs don't really work with their frameworks. So providing example code for both situations is very nice. And yeah, this code is identical. And also, of course, having good documentation, which is its own talk. But the way that I see it is you can fail to say a lot of things, but you really should say like what the domain of your endpoint is. For example, my API has quite a few enums, but that's intentional. That's a performance decision, because it saves nanoseconds in the case where you're only trying to parse something very particular. So I provided a list of enums for people to use, and it's just a great performance improvement. And also linking to external documentation when using a standardized format is really nice. Don't have people try to determine your format from scratch. Even an anecdotal story about this is the case of I tried to fine-tune a private large language model for a school class, and I found that the format for the JSON file for fine-tuning is just difficult to find online. And I was just kind of in awe of the fact that none of these projects mentioned what the data format was. I really wanted to use their API, but they didn't document how to use it. Also, yeah, you want things to be compatible for a long time. You don't really want to deprecate things. So maybe you could add endpoint prefixes, which is really common. You see v1 all the time. But also backwards compatibility is really nice. And yeah, advertise changes when you make them, and try to choose good UIDs at the beginning, because people will probably be saving those UIDs in their own database. So you don't want to basically make a dead UID for them. That would be a shame. And the way I did that is in the blog post that I documented my Google Street View reverse engineering, I reported that an endpoint on Google's side had changed. Of course, this is reverse engineering we're talking about. This is a private API, so Google doesn't really need to report that. But it's just nice to tell people when things change. And I have a section on the APIs I think are done right. Like GitHub is a really popular example. And their requests are made using GraphQL, which is extremely powerful and fixes quite a few of the problems described in this talk, simply because of how powerful it is. But it also enables a lot of abuse of your API. It's a very finicky thing. But it's nice that they have a webhook API that triggers whenever you make a pull request or make a commit. That is a really useful live feature for users to use. And also they have pagination because it's GraphQL, which is a good example of how to handle quantity. They have a lot of endpoints, quite a few, just an unimaginable amount. You can get, there's an endpoint for the emojis you can use in pull requests, which is, and you know, on the discussion page, which is really funny. And also they provide a lot of example code for both curl and JavaScript, which is the example of having code for both a raw network requests and the client library. And Hacker News is another good example of that, and they're very open about this. They advertise their API as being a dump of their in-memory data structures, which is an amount of freedom that a reverse engineer can only dream of, really. And yeah, they're extremely fast API. The amount of data is not extreme, but it's clear that this was a bunch of developers who really cared about the users of their API, so they made it very fast, and also payloads are very small. And they also provide this public incrementing ID that you can use to walk backwards through every post ever made, which is just an amazing example of quantity. And I know it's bad practice to have a public ID that's simply incrementing, but in cases where that data is not sensitive, it's extremely nice to have all of it. And also they prefix endpoints to preserve compatibility. And on the right here is a custom client for Hacker News that just shows that their API is so good that someone remade their entire client, which is just a standard of quality, really, for an API. And also, OpenStreetMap is a really exceptional example of an API. They have really good latency by providing bulk downloads of their entire data set. So you don't even need to depend on them anymore. You can download just a huge tar file of everything they own, and then they give you the libraries to process that data. So it's more an example of a data set. But where OpenStreetMap shines is they're not just a data set provider. They have a good blend of both bulk downloads and individual downloads, like reverse geocoding. They also, yeah, that's quantity. And coverage, they are comprehensive enough to replace Google Maps, and some users do that. For example, Wikipedia uses OpenStreetMap as their way of showing places. And that means they don't need to pay for some license from Google. So OpenStreetMap is serving a really important purpose here. And also they're extremely high quality because they have high compatibility with existing software. They basically follow all the standards. They also invent most of the standards. They're like, that's why people talk about OpenStreetMap even if they're using Google Maps. It's because the standards OpenStreetMap created are the ones Google Maps adopted. And also they have a very large active volunteer network. These are people who are having fun contributing to an API. And, you know, if that isn't a standard of quality for an API, then I don't know what is. And just two examples of APIs that are really just on extreme opposites. But on the left, this is the official Mario Kart 8 Deluxe record speedrun leaderboard. And this is what users actually use to determine whether they got a world record. It's a really exciting service because speedrunners are constantly watching this leaderboard to see who's currently in possession of the record, and it leads to some really just exciting moments. And this data was obtained by accessing the Nintendo API. And they also expose this data to other people. So it's just an API that encourages people to have fun with video game data. And also this on the right is just like a coverage map for a telecom company. And you're not looking at this to have fun. You're looking at this because your phone is not working and you need to call home right now. But luckily, this service is extremely easy to access. You can just Google like coverage map and it'll give you cell by cell. And the cells here, this is DIA, Denver International Airport. I'm from Denver. These cells are probably in the realm of like 10 meters by 10 meters, extremely granular data. And that'll really tell you immediately how good your internet actually is. And they easily could have made a shortcut and said, oh, Denver's working. And it's like, really? Well, it's not for me. Where does Denver start? I'm in DIA. DIA is like 10 miles outside of Denver. Is that still Denver? No, they give you a map that'll give you extremely granular data points. And that is the talk. These are my sources.